Okay, this is Math 116, 6.5, and this is loans and amortization. So the problems are all going to involve you borrow some money and you're paying it back, essentially. And we're going to see two formulas in here. We're going to see our straight up kind of amortization formula, and then we're going to have a second one a little later in the section for unpaid balance. And so I think, let's see, we've met most of these things. The one new one is this A sub n, and that's going to be the amount of the debt. So like say we borrowed $10,000 for a car that we're going to pay off over 36 months. The $10,000 is the amount of the debt. Everything else I think we have already worked with, so I will head into a problem. Okay, number one goes, a recent graduate student loans total $16,000. If these loans are at 5% compounded quarterly for 14 years, what are the quarterly payments? So let's start our list. So A sub n, this is going to be the amount that's being financed over the n periods. So that's 16,000. Rates 5%. Compounded quarterly, so M is 4. 14 years, T is 14. And then we'll do our two calculated ones. So I, it's still rate divided by compounding periods. That's going to be 0.0125. And then N is still compounding periods times time, so that's 56. And from there, we're pretty much plugging in. So we're finding the payments. Oh, and we're finding R, because it was, what are the quarterly payments? So $16,000 got financed, and then this goes I, so 0.0125 over 1 minus 1 plus I. So that'll be that 1 plus this to the negative n 56. And throw all that in the calculator, and it looks like the quarterly payments would be $399.00. Okay, question 2 goes, a homeowner is planning a kitchen remodel and can afford a $700 a month payment. So that's our R. How much can the homeowner borrow? So that's the amount that they're going to be financing. So that's at A sub n. For 4 years, T is 4, 6% monthly. So R is 0.06. Monthly makes M 12. And stay within budget. Okay, so we still need I. So again, that's rate divided by compounding periods. That's 0.005. And we still need N, which is T times M. So that would be 48. And then I'll cut away, put all this in the formula, and cut back. Okay, so I set all that up. This time we knew R, so we're plugging in on this side, and we're solving for A sub n. So putting this in a calculator, I got something like 0.023, and then divide that over, and A sub n is $29,806.22. So that's how much they can afford to borrow with $700 payments on those terms. Okay, last formula for the quarter, and this is unpaid balance or payoff amount for a loan. So we got a couple of new things. We have K, which is the number of payments that's already been made, and then we have A and then N minus K as a subscript. And so this is going to be the unpaid balance. So it's the total payments minus how many are made, and that's saying how much is left. And so we can use this to figure out, like, if we have a 5-year car loan, and after 36 payments, after 3 years, we want to see how much we still owe on it. This would be the math that would figure that out. I think everything else is all stuff we're familiar with, so I'll head into a problem. Okay, number 3 goes, a $10,000 loan is to be amortized for 10 years with quarterly payments of that much. If the interest rate is 8% compounded quarterly, what is the unpaid balance immediately after the 6th payment? Okay, so we know we have this A sub n. This is kind of our starting amount of our loan. And it's going to turn out we don't need it. So I'm just going to put a little star by it, but just say, just to show I'm noting it. T is 10 years. Quarterly payments, so M is going to be 4. And the payments are that, so that's $365.56. That's our R. Rates 8% compounded quarterly. We already got the quarterly, so little r is 0.08. What is the unpaid balance immediately after the sixth payment? So remember, K is the number of payments made. And so immediately after the sixth payment, K would have been, they've made 6 payments. We still need I, and that was rate divided by periods, so that would be 0.02. And then we still need the total number of payments, so 10 times 10 years quarterly, so that'd be 40. And that's our N. And now I'm just going to kind of plug into, this time I'm using this formula right here. And again, I'll cut away, write all that up, and then come back. Okay, here it is all set up, and we are solving for, again, the unpaid balance, which is at A sub N minus K. We throw all that in the calculator, and we get, that would equal 8955.71, so $8,955.71. So this is how much they still owe on that $10,000 loan after they've made 6 payments. Or when Maria bought a car 2.5 years ago, she borrowed $13,000 for 48 months at 6.6% compounded monthly. Her monthly payments are $308.89, but she'd like to pay off the loan early. How much will she owe just after her payment at the 2.5-year mark? Okay, so the 2.5 years ago, so this is going to be, she's been making payments for 2.5 years. So if I go, and this is going to be our K, 2.5 times 12, because 12 payments a year, 2.5 years. That means so far she's made 30 payments. And again, remember that K is the number of payments already made. 13,000, again, I'm going to put an asterisk on it. That would be A sub N, but we're not actually going to need it because the unpaid balance doesn't use that. It used the payment, and then it finds the unpaid amount. But I'll just note that's what that is. 48 months, so that would be N because they gave it to us monthly. They could have said 4 years and then compounded monthly, and then we would have gone 4 times 12 to get the 48. But here we can go straight to the N. Rate 0.66, and then again M was monthly, so that will be 12. Payments right there are $308.89, and then what else do we need? We need little I, and so that's going to be 0.0055. And that was just doing rate over compounding periods. And then last, we are solving for A and then N minus K. So that's that unpaid balance. So again, I'll cut away, set all this up, and then come back. Okay, so then we just throw that in the calculator, and I got it to come out to 5279.86. Okay, question 5. This one has a couple of parts. John Fair purchased $6,000 worth of equipment by making $1,000 down payment and promising to pay the remainder of the cost in semi-annual payments over the next 4 years. Interest rate on the debt's 8% compounded semi-annually, and then find the following. So first up, we're finding the size of each payment. So our amount financed, that was that A sub N, is going to be $6,000 less the $1,000 he did as a down payment. So that would be $5,000 is how much he financed. Semi-annual payments, so M is going to be 2 over the next 4 years, so time is going to be 4. Interest rate 8%. I would be that divided by 2, so 0.04, and then it would be a total of 8 payments, and that will be our N. And so this one we're trying to find the size of each payment, and what we have is the A sub N, so this is where we're going back to our plain amortization formula, because we kind of have these two. We have this one that does unpaid balance, but there's nothing here about unpaid balance. We made a down payment, we financed $5,000, and then that's our terms. So that's just a regular old loan, so that's going to send us back to this formula. And so to do the payments, we'll do R equals A sub N was 5,000, And then I 0.04 over 1 minus 0.004 negative 8. And then we just throw all that in the calculator. It's 742.64. So that's going to be our payment amount. And then part B is find the total amount paid over the life of the loan. So we had 8 payments. It was right there at this much, except the computer is kind of not nice. When I tried this one, I had to put it in with all the decimals, and when I did that, I got 5941.11. So it should just be 8 times this amount because that's the payments, but there's some kind of rounding happening in there, and so I think it gets marked wrong if you don't use all the decimals. But so there's how much they're paying back. And then C is the total interest paid over the life of the loan. So he paid back $59.41.11. He borrowed originally, remember, $5,000. So then that makes his interest $941.11. Okay, number 6. A couple who borrowed $50,000 for 30 years at 8.4% compounded monthly must make monthly payments of $380.92. A, find the unpaid balance after the end of the first year. Okay, so unpaid balance, that means we're using that second formula. So we'll kind of get things set up for that. So we're looking for the unpaid balance, so that's our A, N minus K. The original amount they borrowed was $50,000 for 30 years, 8.4% interest, compounded monthly, and payments of that. 0.92. Okay, so we got our list going. We still need I and N. So I is going to be this divided by 12, which is 0.007. And then 12 times 30, so that'll be 360. So 360 payments. And so now we can figure out what the unpaid balance is. So A, N minus K. And so again, I'm plugging into this formula right here. And so here it is all set up. I just throw all that in the calculator. And that gave me $49,614.50. So that first year that they borrowed this would be like a mortgage, except it's much too small for Seattle. But in that first year, they only paid off, like not very much money. They borrowed $50,000. They still owe $49,600 after making all these payments. So they totally get you that first year on mortgages. Which leads us to part B, which is during that first year, how much interest do they pay? So the total payments would have been 12 times the payments. So that'd be $45.7104. So the principal paid in the first year. So they borrowed $50,000, right? And their unpaid balance is that $49,614 that we just found. So that means their principal in the first year is only $385.50. So of all that money they paid, that's how much actually went to paying off the loan. So then their interest is going to be the difference on that. So how much they paid minus the principal, how much actually went to paying off the loan, and then $4,185.54 is how much the bank made.